Okay, in this video, I'm going to show you a couple more formula on the how to find a Laplace transform. Do you remember that one formula that we discussed? If Laplace transform of let's say f of t equals to uppercase f of s, then what is the Laplace transform of e to the at ft? So do you remember that? So if this has Laplace transform as uppercase fs, then if you multiply the original function small lowercase ft by e to the at, then that will be s will be replaced by s minus a, right? So if you multiply the function ft by e to the at, then the formula for the Laplace transform will be s will be replaced by s minus a. But if you multiply ft by other function, for example t to the n, so then what will be the formula? That's what we are going to write next. Suppose ft is piecewise continuous in the interval 0 is less or equals t is less or equals to a and of exponential order a, okay? Then for every positive integer n, the Laplace transform of t to the n times ft. So not e to the at, because we have the formula for e to the at times ft already. Now if you multiply by t to the n to the function ft where n is an integer, then the formula for this will be -1 to the n, okay, -1 to the n, the nth derivative of the Laplace transform of the function ft. So it will be nth derivative, right? This is dn over dsn, nth derivative of the Laplace transform of ft, where Laplace transform of lowercase ft is uppercase fs. So nth derivative of Laplace transform of ft, that is nth derivative of Laplace transform of nth derivative of fs. Okay, all right. So let us see one example right away. So find the Laplace transform of t squared sine 3t. We know that the Laplace transform of sine at is a over a squared plus s squared, right? So how do I find out the then? Let's write then. So Laplace transform of sine 3t equals to 3 over 9 plus s squared, right? That's what we get. Now if you multiply this by t squared, it will be similar to that, right? So what we do is we find out the second derivative, because there is nth derivative, so there is nth exponent, so you find out the nth derivative. There is -1 to the n on the first. So similarly, if you multiply this by t squared, hence Laplace transform of t squared times sine 3t equals to what? So it will be -1 to the n is 2, right? And then you do d second derivative, right? dsn, so that function, right? The Laplace transform of the original function sine 3t, so 9 plus s squared. So how do I find out that? That will be just the quotient rule, right? -1 square, okay? So how do you do that? It is like f, this is like g, right? So f prime times g minus f g prime, right? F times g prime over g square, that's what you do, right? So how does that look like? It will look like, so, oh, this is square, right? This is square, okay. So what you do is basically -1 to the square, and then it is you don't have to write -1 to the square. So how much is that? Is -1 to the square is +1. You don't have to write that. So you need to find out the derivative twice, right? Let us see what is the derivative of 3 over 9 plus s squared. First time you need to do that. So f prime is 0 times g, 9 plus s squared, right? And minus f times g prime, 3 times 2s over 9 plus s squared to the square, right? How much is that? -6s over 9 plus s squared to the square. This is the first derivative. Let's find out another derivative of that, okay? So how that look like? That will look like, so 3 over 9 plus s squared to the double prime, which is same as -6s over 9 plus s squared to the square, okay, to the single prime, right? So what do you get here? So we need to use the quotient rule again. So f prime times g minus f times g prime over g square. You see that? So how do I find out that? That will look like f prime. This is like f, this is like g, right? So f prime is negative 6 times g is 9 plus s squared to the square minus f times g prime. So minus negative 6x will be positive, right? 6x times the derivative of that. You need to use the chain rule, right? It is like u to the n, u squared. So 2u and then times u prime, right? So that will be 2 9 plus s squared times 2s, because 2u to the 2 minus 1, that is just 1, right? Times the derivative of the inside is 2s. Divide by, you got 9 plus s squared to the fourth, because the square of z, right? Z square will be to the fourth. So if you simplify this, how do so if you simplify this, what do you get? Let me rewrite this in little nicer form. Negative 6 9 plus s squared to the square, and then plus 6x times 2 is 12 times 2s is 24s square, and what is left is 9 plus s square, right? Divide by 9 plus s squared to the 4. What is common between these two? So 9 plus s squared is common, right? So let's write down 9 plus s squared common. What is left here is 9 plus 6, negative 6 times 9 plus s square, right? And here 24s square. Here that will be 24s square, right? Because 9 plus s square is taken out already. Plus 24 s square, right? Divide by, there is a big parenthesis there, okay? Divide by 9 plus s squared to the 4. Now let me write out here. So how does that look like? That looks like I'm cancelling 1 9 plus s squared with one of the 4. So what I got here is negative 9 times 6 is 54 minus 6s squared plus 24s squared, right? Divide by 9 plus s squared to the third. So how that look like? That will look like, so that and that will be so 24s squared minus 6s squared, 18s squared minus 54 divided by 9 plus s squared to the third. That's what I got, the second derivative. So what you get basically is positive 1, because negative 1 squared is positive 1. The second derivative of this is 18s squared minus 54 divided by 9 plus s squared to the third. You see that? That's what you get. Okay, so that is basically the application of this formula, the direct application of this formula. So sometimes if there is like t to the 3 or t to the 4 like that, then you will have to find the derivative many times, right? If there is t to the third, then you will have to find the derivative 3 times. If there is t to the fourth, 4 times. That might be tedious, but we can do it. If you take ft equals to 1 in this formula, then what do you get? So ft equals to 1 implies Laplace transform of t to the n times 1 will be just Laplace transform of t to the n. That's what you get, right? So Laplace transform of t to the n equals to negative 1 to the n times, what is the ft, what is the Laplace transform of 1? Ft equals to 1. So the Laplace transform of ft equals to 1 is fs equals to 1 over s, right? So you'll have to find out the nth derivative of 1 over s. Okay, so how do I find out the nth derivative of 1 over s? Let us see here. So here the derivative of first derivative of 1 over s is s to the negative 1. The first derivative of that, it will be negative 1 to the times s to the negative 1 minus 1, right? So that will be it is basically negative 1 and then s to the negative 1 minus 1, right? So it will be negative 1 times s to the negative 2, right? But it will go down, so it will be negative 1 over s squared. So if you want to find the second derivative of this, which is the first derivative of the first derivative, right? That is, you need to find the derivative twice. So you need to find the derivative of this one as well. So the second derivative of this 1 over s is the first derivative of negative 1 over s squared. So if you do that, you will get 2 over s cubed. See, there was negative first derivative, negative, second derivative is positive. If you find out the third derivative, then you will find out the derivative of the second derivative, right? 2 over s cubed prime. That will give you negative 6 over s to the 4. That is negative 3 factorial over s to the 3 plus 1. So if you continue that way, you will see one term positive, one term negative, positive, negative, like that. So if the derivative is the odd derivative has negative sign, even derivative has positive sign, right? You see that? Second derivative has positive sign, fourth derivative will have positive sign, and so on. So in that case, what you do is, so basically the nth derivative of this function 1 over s, nth derivative will be negative 1 to the n. If n is odd, it will be negative. If n is even, it will be positive, right? So negative 1 to the n, and you see that n factorial, if there is third derivative, then it is 3 factorial over s to the 3 plus 1. If there is second derivative, there is 2 factorial over s to the 2 plus 1, right? You can write that way. You see that? So basically what you can write here is 2 factorial over s to the 2 plus 1. For the third derivative, right, you have 3 factorial over 3 plus 1, but there is negative sign for the odd. That's why I wrote negative 1 to the n. So if n is even, it will be positive. If n is odd, it will be negative. So n factorial over s to the n plus 1. This is what I get the nth derivative. So here, the nth derivative of 1 over s is negative 1 to the n factorial over s to the n plus 1, right? So from the formula, there is negative 1 to the n. So there is another negative 1 to the n. So if you multiply that, you will get a negative 1 to the n times negative 1 to the n will be negative 1 to the 2n, right? You will see negative 1 to the 2n. You see that? And then that will be negative 1 to the square, and then write n, right? So that will be 1 to the n. So it is n for the finite integer n. You see that? So what we got basically, so the formula here is, this is what you get the formula. So the formula is, if you are finding the nth, the Laplace transform of the t to the n, right, then the formula is n factorial over s to the n plus 1, where s is positive. So the, and one direct application of that, let's say let us see an example. Okay, if you see an example, so what will be the Laplace transform of t to the cubed? So it should be by that formula. It will be 3 factorial over s to the 3 plus 1, right? So it is, what is 3 factorial? 3 times 2 times 1, right? So it is s to the 4th, that is 6 over s to the 4th. Similarly, if you find out the Laplace transform of t to the 10, then that will be 10 factorial over s to the 11, right? But one of the important thing you should note here is, if n is an integer, then this formula is applicable. But if n is a fraction, then we use slightly different formula. That's the next thing we are going to discuss. Okay, if n is a fraction or non-integer values or negative values, so or this n, if this n is non-positive integer, okay, so n is n is a positive integer. Let's say non-negative integer. I think that's good. If it is a non-negative, if it is non-negative integer, you use that formula. But if n is negative, or if n is any fractional values, right, in that case we'll use slightly different formula. So I'll derive that next. All right, guys. So if n is a non-negative integer, 0, 1, 2, 3, 4, like that, then the Laplace transform of t to the n is n factorial over s to the n plus 1. Okay. Okay, the next thing that we want to discuss here is the Laplace transform of t to the alpha when alpha is greater than -1. So any alpha, okay, so alpha can be a fraction, alpha can be -0.5 and so on, but alpha must be greater than -1. Okay, so so what is the Laplace transform of t to the alpha? It's just use the formula 0 to infinity e to the -st times ft, right? So f is basically t to the alpha dt. S is positive, and then alpha is greater than -1. So how do I do this? Is I set u equals to st. For this st, I want to set u. Okay, then what will be du? Du will be s dt, right? We are finding the derivative with respect to t. So the Laplace transform of t to the alpha is e to the -u, right? And how do you replace t? So t will be u over s to the alpha, and then times dt is 1 over s du, right? That's what we get. Now you see that you can distribute that alpha to the u to the alpha divided by s to the alpha. So there is s to the alpha, there is s. So s to the alpha plus 1. since this integral is with respect to u, so you can pull that s out, 1 over s to the alpha plus 1, and then you can write 0 to infinity e to the negative u to the alpha du. The one of the thing that you should be careful here is with this substitution, these are the limits for t, right? When t is 0, then u will be 0, right? When t is infinity, u will be infinity as well, because s is a positive number, okay? So this the substitution does not change the limit here. So the limit is still 0 to infinity there, okay? So now here, what I'm trying to do is when I pull that x to the alpha plus 1 to the front, 1 over that to the front, then what is left is 0 to infinity. I just put u to the, I just wanted to match with alpha plus 1 there. So I wrote u to the alpha plus 1 minus 1, okay? And then e to the negative u, all right? So what you get here is this is basically gamma alpha plus 1 over s to the alpha plus 1. This integral is basically gamma alpha plus 1, or you can say where gamma alpha plus 1 is given as e to the alpha plus 1 minus 1 times e to the, sorry, u to the, this is u to the, okay? So u to the alpha plus 1 minus 1, u to the alpha plus 1 minus 1 times e to the negative u du, and the limit is 0 to infinity, is called the gamma function, okay? Hence the Laplace transform of t to the alpha for any alpha greater than negative 1 is gamma alpha plus 1 over s to the alpha plus 1. You see that this is gamma alpha plus 1, but what is the exact value of the gamma? If there is like gamma alpha, what will be that? It will be 0 to infinity, and then u to the alpha minus 1 e to the negative u du, right? That's what the value of the gamma alpha. You see that? Because there is gamma alpha plus 1, we need alpha plus 1 there. If there is just alpha, then you will need just alpha there, okay? All right, so that is the value of the gamma function. Now the Laplace transform of t to the alpha for any alpha greater than negative 1 is gamma alpha plus 1 over s to the alpha plus 1. Okay, so some of the properties of there are some of the properties of the gamma function. There are many properties, but I'm just using just few that we will need later on, okay? So gamma of n plus 1 equals to n factorial if n is a non-negative integer. If n is a non-negative integer, we use exactly the same formula. It will be n factorial over s to the n plus 1, right? But so therefore gamma n plus alpha plus 1, or the n plus 1 will be t to the n, will be gamma n plus 1 over s to the n plus 1, right? But if n is the integer, then gamma alpha plus 1 is basically n factorial, or gamma n plus 1 will be n factorial. So also the another property we will need is gamma x plus 1 is x times gamma x, where x is positive. X can be anything, fraction or anything, but x must be positive. And gamma of 1/2 is root pi. So this has some work, so I skip that for now, okay? So gamma of 1/2 is root pi, okay? So how about the gamma of 3/2? Gamma of 3/2 can be written as gamma 1/2 plus 1, right? So what do you get there? Gamma 1/2 plus 1. So gamma x plus 1 is basically what? So x times gamma x, right? So what you can do is you can write 1/2 and then gamma 1/2, right? Because see, if there is x plus 1, this will be x gamma x, right? So what is that? So 1/2 times gamma 1/2 is root pi. So basically it is root pi over 2, right? Gamma 3/2 is root pi over 2. So similarly you can do gamma 5/2, 7/2 like that, okay? So these are some of the properties, and then the Laplace transform of t to the alpha for any alpha that is greater than negative 1. And these are the homework problem from section 5.2. I think I assigned that already in the last slide, but just in case if I have not. So section 5.2, question number 3, 4, 2, 3, 4, 6, 7, 13, and 17. All right.